Let's have a look on the computing capabilities of this calculator. The calculator can basically do two things: remember values and compute new values. The remembering part can be done thanks to the variables. Some might be visible, like the display of variable x, and some might be hidden, for instance, to remember the previous number typed after typing in a symbol. And then we can compute new values using methods. For instance, we can add two values, or subtract, or multiply. We might have, like here, the methods corresponding to the basic arithmetic operations, but also other ones to get or set variable x. When we write a program to model this calculator, and we define variables and methods for it, we will be a bit organized and put, on the one hand, all the variables together, and on the other, all the methods together. We call the values of all variables at a particular moment state, and the set of methods applicable, we'll call them behavior. Our models are going to change from one state to another state as time advances. A particular state is going to be determined by the values of the variables, and the methods are in charge of the state transformation. It turns out that determining the variables and methods is a very general way to model objects computationally. These objects may correspond to physical ones, like calculators, or conceptual ones, when your code has to model something new. So this division of state and behavior is very powerful. We're trying to visualize now different examples and identifying their state and behavior. For instance, model a hiker. You might need that for a program you're writing. What can be possible variables that make up the state? Of course, it depends very much on what you need to program, but it could be, for instance, the location of the hiker expressed in some coordinate system, or the contents of the backpack, or is tired, is hungry. This might be Boolean variables. As I said, it depends very much on what you need to program, but you get the idea. And what are possible methods? Could be, for instance, walk n units in a particular direction, or put something in the backpack, or take something out, or eat in order to be hungry anymore. Methods typically change state. For instance, if the variable is hungry is true at some point, calling method eat takes us to change this variable to false. Or putting something in the backpack changes the contents of the backpack. Another example. Now imagine a car, which is modeled in your program that you wrote for a game. States can be location, color, whether headlights are on or not, and methods can be change position, turn the lights on, etc. Remember that methods are often related to verbs because they imply an action. Now we are going to encapsulate variables and methods into a new programming construct called object. This concept of encapsulation is one of the key concepts in the so-called object-oriented programming paradigm. So remember, objects have state, represented by individual variables, which are also sometimes called fields or attributes, and behavior, the things our object can do, is represented by methods. These two components, state and behavior, are not spread out in the program. They are put together and encapsulated into objects. Are you ready to take the capsule and dive into the world of object orientation? Let's go.